CubeSats is the number one way for innovation in space research. That's because they're significantly cheaper than conventional satellites and have easy access to space via a rideshare program. The main constraint, however, is the low average power generation due to their small size, meaning they have limited surface area on their external walls for solar cell assembly. We are the Shape Memory Lab, and our solution introduces additional surface area for solar cell assembly. This is made possible by an origami-inspired solar deployment method, which utilizes shape memory alloys as actuators.
The shape memory alloy we use in our design is superelastic nitinol. The superelastic effect is advantageous because it provides a constant stress response over its strain distance. This allows our origami to collapse without excess folding stress and deploy in a controlled fashion. To solve the energy problem, we came up with a design that can be split into 3 parts. First, we designed an origami-inspired folding flasher. Once deployed, it will provide the additional area required for our solar cell assembly. As a result, our solar cell assembly alone provides almost 3 times greater energy generation than a typical 3U solar solution. We fabricated our prototype using 3D printed ABS and assembled it by hand. The driving force of the unfolding comes from superelastic nitinol hinges embedded in each panel. Next, we designed a mechanism to raise the stowed flasher from inside the CubeSat above clearance level so it can be deployed and also support the unfolded flasher. Both the folded flasher array and the linear actuator are retained in their storage configuration by a burn wire mechanism.
Lastly, a remote relay switch will be placed to wireless communicate and activate each phase. When the button is pressed, a high current circuit will be turned on to burn the wire and then deploy the solar panel in each phase. This will be integrated into the electrical system of a real CubeSat. Here's our final design with every component integrated into the CubeSat. There are 2 main stages to deploy once in space. First, the actuator is raised, then the flasher is unfolded. And here you have it, our design fully deployed. Enjoy the extra energy.
In conclusion, this design sacrifices payload volume for a massive power increase. In addition, the strict manufacturing tolerances and potential for deployment risk are a significant consideration for CubeSat operators when selecting their power solution. This project made us realize that shape memory alloys is one of the best options for complex actuation, and it pairs really well with origami. We believe that there's much more to explore with origami structures used in space.